Hello everyone, Mr. Mesco here, and today we're going to take a look at the circulatory system and the oxygen levels and carbon dioxide levels for the different parts of the heart and different blood vessels around the body. So, with that said, get yourself a Google Sheets document. You'll put these labels, whether you want to put them across or vertically like this, and then in my case, I'm going to start right here. I'm going to put the averages here in this column, and then the 6 measurements are going to go right here. So we go ahead and take the syringe. We can put these labels here if you want to, but it's not necessary. We take this syringe and starting with, let's go ahead and close these other things. Starting with the right atrium. If you go ahead and put it in the right atrium, it will give you 36.1 and 46.6. I went ahead and made some changes, so here's our 36.1, 46.6 for carbon dioxide and oxygen. Just put some color coding here to denote that oxygen is in red and that carbon dioxide is in blue. And we'll go ahead and do this 5 more times. So 34.5, 46.8, 34.1, 46.3. Here is our 5th sample. And our last sample, we'll go ahead and put the formula for average, select the range that we want. What? Did I miss this? Here we go. And then what you can do is you can click and drag. We have learned this from the past. And just to confirm, you can double click it. It will highlight the sections that you want. Wait, did we go up to 6? 34 point. We're missing another one. Alright, here's our last one. If there was any glitches here, I've been pausing and resuming the video just in case you're wondering. There's no editing in this video. I stopped editing a long time ago because it just takes a long time. Anyway, let's continue. So here's our last one. We have too many decimals, so we'll just go ahead and bring that down to 3 significant figures because the rest of our numbers are in 3 significant figures. There you go. So go ahead and do the same for the right ventricle, pulmonary artery, pulmonary vein, all these. You know, get those labels from me, from your teacher, whichever image I'm giving you. Get those labels, but in essence, you go from here to here. At some point, it will ask you for the pulmonary artery. You'll notice that the pulmonary artery can be here or here. Then the pulmonary veins are here. So the heart pumps blood from the right side to the lungs. The lungs fill up the blood with through diffusion with oxygen. Now oxygenated blood comes back to the left side of the heart, and then it goes out into the aorta. So when you're looking at aorta, you can just take measurements from anywhere that represents the outflow of oxygenated blood, which could be somewhere here. You'll notice there's a lot more oxygen than carbon dioxide. Could be here, 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 or here. And then likewise for the vena cava, you can take any measurements that are coming back from the cells after dumping the oxygen and picking up carbon dioxide. Places like this or like this, here, any of those places that eventually lead back to the superior vena cava and the inferior vena cava. And so here's what you do. You take the syringe, let's go to vena cava, right? We said you could measure it here, here, here. There's some people passing by. Alright, I think we're good. Okay, so you take, vena cava, you can measure it here. Here's what I'll do. Vena cava, take those measurements, take those measurements, take those measurements. It keeps changing, and that's the cool thing about this gizmos. It keeps changing. Whoa, hey. I'm sure at this point, if you began to do this, you might be tempted to do something, right? You might be tempted to get my numbers. Or you might be tempted to make up the numbers. Don't do it. It's called dry labbing. It's frowned upon in the scientific community. It's frowned upon in IB. Hey, uh, put on your favorite song, put on a podcast. It took me 5 minutes, perhaps less. I seriously just paused the video or finished watching a video. Sorry, from Trevor Noah, from The Daily Show, and it was about 5 minutes. It took me 5 minutes to do this. So anyway, I clicked and dragged this all the way to the bottom. Therefore, it copied the formula for all these to simply take the average of all these rows. And then I went ahead back in and color coded, because copying the formatting copies the color. But hey, here it is. And so now what we're going to do is the most important part, which is processing the data by doing something with it. In this case, we take the averages or the means, and we're going to graph it. Then, since the formatting didn't fit, I couldn't go ahead and select this and then create a chart from that. What I did, I just had to copy that, paste it over here, with the appropriate places. Here's the oxygen, 35.3 and 35.2, and you can see that. And then I can now select that, create a chart. Of course, this does not tell a good story. So what we want to do is track a trajectory, and for that, a more appropriate graph would be a line graph. What we're going to do is we're going to customize it a little bit, put some labels, title it, and all that. And here is almost a final product. A few things that I did, I actually had to swap the colors. Oxygen was in blue, and so I gave it more of a blood red color, dark red. I put some labels here. So I tweaked a lot of things so that, again, the emphasis is more on the trends and not so much on the other details. Part of your IA or any lab report is ease of understanding, being able to follow the story, being able to follow whatever the data is telling. And in this case, the labels are here just in case somebody wants to see a spike or wants to take a percent change. But other than that, I made them smaller than usual. I put some dots here, put some label here on the side, and this is it. So so I hope this was helpful, and I will see you in the next video. Pachung!